doesn't provide as much tissue. And the concentrations, because they're predators, are high enough to analyze using the direct mercury analyzer, which is an instrument that's much less expensive to operate than some other types of mercury analysis. We've also found in this project, and coming out soon in some national park work, that greater than 85% of the mercury in dragonfly larvae is in the methyl form, which is really important for biosentinel. This will allow us in the future to simply analyze them for total mercury, which is much less expensive, and assume that that represents the body burden of mercury that could be passed up the food web. And in my citizen science piece, I'll mention that they're easy to recognize with minimal training. We work with a teacher who always says the kids don't take long to get their dragonfly eyes on, which is true. Once you've kind of seen a few of them, you can recognize them. So here we'll get into what we did in this project. So we have another data set and set of lakes that I work on as part of US EPA's LTM network. And there are 74 time lakes. TIME is an acronym for Temporally Integrated Monitoring of Ecosystems. And we sampled them in late summer of 2012. I'll briefly talk about the lakes in a moment, but this is a map showing where they're located. There are approximately 40 lakes in the Adirondack region, and the rest are spread throughout New England. Again, Vermont only has one lake. Sorry about that. And there are a few in Maine as well. So the dots on this map, again, are showing us concentrations of methyl mercury now in lake water. And again, we've got a relatively high one in Maine and in the Adirondacks. So these lakes, as I mentioned, are part of the US EPA